Hi, my name is Raj, and you are welcome to my channel. I'm running a video course on generative AI, and this video is the next chapter on that. And as part of generative AI, first I'm covering the deep neural network because this is very essential if you really want to master generative AI. And in my previous two videos, I have covered about the basic concept, but like introduction, like what is deep neural network, how it works, what is the mathematics behind that, what is the graphical concept behind that. So if you have not seen that introduction video, I will highly recommend go and watch those videos. In this video, what we're going to cover, I'm going to start the first chapter of deep neural network, which is called Perceptron. A lot of people ignore this topic because I find that, but according to me, I find that's very introduction or it's a background. Okay, before starting the deep neural network, you should know about the perceptron, that how the perceptron work, what are the maths behind that, because it was the foundation to start the journey of deep neural network. Okay, so in this video, I will talk about the basic concept, what is the perceptron, and in upcoming video, I will talk about more about perceptron. Okay, so let's get started in this video and let's understand how the perceptron model work in deep neural network and how it is important. Okay, so let's get started and let's discover perceptron in deep neural network.
So why we should learn about perceptron? And a lot of people actually ignore this part. They just jump to neural network directly. They don't discover. They don't learn about perceptron. But why I'm giving a lot of stress of perceptron, because it built the foundation. Okay, if you see that this model, it was the first model, and it is not very new model, by the way. It was used in 1957, around 1960. Okay, it is very long time back, and it was introduced by first Frank Rosenblatt. Okay, so you can see that it's a very old model. This a lot of people was already working on perceptron. Okay, and it was primarily used for binary classification problem. So in 1957 and 1960, during this time, it was kind of a revolution this time, and first time the researcher introduced that without using ML, we can solve a classification problem using perceptron. Okay, so during that time, it was a revolution, but it has a lot of problems that we will discuss later. Okay, so it is a foundation. If you why I'm asking to learn this concept, because it is setting the foundation. It is a foundation for neural network. Okay, deep neural network. So that is why I'm giving a stress to understand the basic concept, how it works, then you will have the basic foundation. Okay, so let's start our class and let's understand the perceptron model. Okay, so in this class, how I will going to teach you, I'm going to teach you in two ways. Okay, first I will try my best to explain the mathematical aspect, I mean the math aspect of uh, perceptron. Okay, what is the math behind it? And second, after the maths, I will try to establish a graphical representation. Okay, I will explain you with respect to graph, or I can say it's a geometrical geometrical representation. Okay, so this will be my whole purpose, or I will explain in that way. Okay, so let us understand what is perceptron, and let us understand some mathematical formula, how it works. Okay, so before I explain you what is perceptron, how it works, everything, so let me first uh, let me let me put data. Let's suppose this is my data set, because this is very important to first understand the data set. Okay, so I'm taking very small data set, but it's just to explain the concepts. I'm taking very small data sets. So let's suppose I have a sales data. Okay, I have a sales data, and in that data I have a column like purchase. Okay, so it is giving information whether this product has been purchased or not purchased. If it is purchased, then I'm making a class like 1. If it is not purchased, then I'm saying 0. This is very simple data. So let's suppose I have, just to make it simple, let's suppose I have just two features. Okay, in my data set, I have, let's suppose I have a salary of any person. This is one feature, and what city they belong, which city they belong. Okay, and based on these two combination, I'm classifying whether this person has purchased or not purchased. Okay, so this is my data, very simple data I'm keeping right now. Okay, and let's suppose salary is suppose 2k, and city, for the city is a uh, it's a it's a categorical data, but let's suppose I'm converting into numbers. So let's suppose city is 1, so let's suppose city 1 representing Delhi, city 2 representing Mumbai, city 3 representing Chennai, something like that. We can do the number presentation, right? So suppose that the salary is 2k and city is 1, I'm saying it is purchase. I mean this person has purchased my product. Okay, I'm just giving it very random. Okay, let's suppose my salary is 3k and the person's city is 2, I'm saying it is not purchase. Okay, this is my second data. My third data is, let's suppose the salary is 4k and person belongs to city number 3, then I'm saying 1, I mean they purchase the data. Okay, so this is my whole data set, simple data set. Okay, so here you can see that I have taken only two features. Okay, salary and city, but in real time it can have multiple feature, 2, 3, 4, 5. You can have multiple features, there's no any limitation on that. First, let us understand this concept with the two features, then I will explain these two more than two features. Okay, so now if we have this data set, then how the perceptron model works, what is the math behind it? Okay, let us understand that. So perceptron is also is kind of if you have seen my previous video where I give a very foundational concept, what is what is neural network, okay, what are the neurons. Okay, this, if you have this understanding, so in perceptron, what is the uh, perceptron about? Perceptron had just one neurons. Okay, now you might be wondering, just one neurons, how it is going to solve the problem? Okay, yeah, so initially when this person, researcher Rosenblatt, in 1960 they start working on neural network. So they started with just one neurons. Okay, so in the perceptron there is just one neuron. Okay, and this is one neurons, and this this neuron will accept input. If you have seen my previous video, as you know that, okay, it's a hidden input layer, right? So this is input layer. In this case, with this data set, I have just two features, salary and city. Okay, so so that's why I have only two inputs, because I have two features. So this I can say, I can give a name here. Let's suppose I'm saying it x1. Okay, I'm saying it x2. So x1 correspond to salary and x2 correspond to city. This is my two input, and I have just one neurons. Okay, and as you know that this neuron will connect, this input will connect with this neuron. Okay, and even this x2 will connect to this neuron. This is a concept of neural network which I have already covered. Okay, so there are two inputs coming into this neuron. Okay, and as you know that every neuron has some they receive the input. Okay, and finally they perform some action. Okay, so the action here in this case, okay, we have some action function, or we call it activation function. Okay, so here it can have in case of perceptron, there are multiple possibility. Okay, this action which we have to perform in the input, it is called activation function. There are multiple activation function. It is called activation function. Guys, my handwriting is not good. Okay, so I hope you will forgive me. Okay, so this is called activation function. So in neural network, in perceptron, there are multiple activation function possible. For example, there's a step function. Okay, this is one of the activation function. And then there can be sigmoid. There can be sigmoid function. I hope you have already learned in the machine learning. There can be softmax function. Okay, or there can be linear function. There can be linear function. So these are the activation function generally used in the perceptron model. Okay, what are those? Step function, sigmoid function, softmax function, linear function. I will describe this whole, all the step function, all the activation function, okay, in some other different video. But for right now, for time being, okay, just to make it our concepts simple, I don't want to make it complicated right now. I just want to start with the simple things. Okay. So let's suppose I'm assuming that my activation function is right now step function. Let's assume. Okay. It's very, very simple. I want to keep it simple. And how does step function work? Let me explain that. So a step function is just a function, just like a mathematical function, a step function. And this is a rule. They have followed this rule. Okay. So this is more. This is just like y is equal to fx. If you know the function, right? How the function will represent in maths. So this is the function f. So f is nothing but a rule. Function is nothing but a rule. Okay. So you have some input x and you apply some rule on x, and that rule is called function. Okay. So here rule is that if x, okay, if x is 0 or positive, okay, if the input which you're receiving is either 0 or more than 0, okay, then then y then y will be 1. Okay. Otherwise, if x is negative, then y will be 0. So this is the rule of a step function. I hope you are able to understand. Okay. Again, repeat x. So what is the step function? By the way, what is the function? Function is a rule or set of action we perform on the input. So let's suppose I have input here x. Okay. If the nature of input is suppose 0 or positive, then my my result after the action will be 1. Okay. And if my input is negative, then the action after performing action, I mean the rule f will be 0. Okay. So if I want to represent this whole, suppose I have x axis, y axis. Okay. Let's suppose this is my x. Okay. X is my input. This x is representing this input. Okay. So what I'm saying that if x is, this is my rule, right? This is my input. If x is either 0 or more than 0, is positive, then y is equal to 1. Then I'm saying that it will be 1 constant. This is y is equal to 1. Otherwise, if x is negative, this one, because this is the negative axis, right? So in case of negative axis, my y is equal to 0. I mean this line. Y is equal to 0 is this line, right? This highlighted line. So this is the graph of a step function. This is the graph of a step function. So it is more like a z kind of, this z kind of. This is the step function. Okay. So if x is positive, then it is height is 1. If x is negative, it is 0. This is all. This is what called a step function. Okay. I hope you're able to understand. It's very simple. So step function convert your input either in positive, either in 1 or in 0. Okay. If your input is positive or 0, then your output will be 1. If the input is negative, then output will be 0. This is a step function. This is what it does. Okay. Now, if I able to understand these concepts, I hope I'm removing this. I hope you know what is the step function now. You are able to understand it, right? Now, now come to the math part. Okay. So first of all, again, let me repeat what I cover right now. So here I have one neuron. Okay. This is one neuron. In Perceptron, we have just one neuron, and it will receive the input. Okay. And it has, as you know that if you have seen the previous video, every neuron has some action to perform. Okay. Which is called activation function. So in this case, okay, in this perceptron case, I'm taking a step function as a activation function. And what is a step function? I hope you know that. Okay. If x is 0 or more than 0, then y is equal to 1. If x is equal to negative, then y is equal to 0. This is my step function. Okay. This is my input. Now with this setup, so in any network, one thing I want to talk about, if you're building either ml, uh, machine learning, or neural network, anything. Okay. So there are two important things. Like one is called training the data, one is called training part. Okay. I mean, in this case, you are training the model. First of all, you are building a model. Either it is a ML model or deep neural network, whatever. Okay. You are building a model. And for that building a model, we are doing a training part. I hope this all basic thing was stuff. So what is training part? Training part is like whatever data you have. For example, this is my data set, right? I have salary, I have city, I have purchase or not happen, right? This is my data set. So with respect to this data, right, I have to train my model. This is called training. Okay, I mean, what is the training? I mean, this model will understand the pattern in your data. What the How the data look likes, what are the relationship between data, how the features are connected. So what is the relationship between data? So your model is trying to understand the relationship or the pattern. You can say just like a pattern. Whatever the pattern you follow in the data, your model is trying to understand. So that is called training part. I hope this all basic thing you understand. And after the training, if you have done the training, your model is now able to understand your data pretty well. They have understand the complexity or pattern in the data. After the training, then we say that my model is ready, and this model I can deploy to some anywhere. Okay, and after that we pass some live data and we do a prediction, right? So we perform two things. First, we have to train the model. I mean, we have to show the data to our model. They will understand the data, all the complexity. And once they have done the training, then finally we do the prediction. This is what I think we all know in typical machine learning concept, right? So here first thing, if you're building a neural network like a perceptron model, okay, so first thing what you have to do, you have to train the model. Okay, so first of all you have to understand how the training happens. Okay, so for the training, it's a I will create another video, a very detailed video about how the training happens with respect to perceptron. But here I just want to put a very basic foundational concept or mathematical concept how the training happens. Okay, and I will cover it later. So now let us understand. Okay, so here now let us see that how the training happens. So what I will do here, first I will pass my input, which is my x1 and x2. And x1 it is representing the salary component, the salary feature, and x2 is representing the city feature. I can have x3, x4 multiple. I will give another example. But for just now, because I want to make it very simple, I'm just skipping two features. Okay. Now this, let's suppose I'm passing first row. Okay, I'm passing the first data. I mean, x1 is equal to 2k and city is 1. Okay, and I'm feeding this data to my model, and my model will try to understand what is the pattern in this data. Okay, so what here, one thing, I'm using some notation. If you have seen my previous video, then as you know that every input, okay, whatever input we assign, how the networks work, how the deep neural network works, we have seen in my previous introduction video. We have to assign weights. So every input has some weights, right? So for this neuron, okay, with respect to x1 or with respect to x2, we have to give some weight. So I'm giving for x1, with respect to x1, I'm saying that weight is equal to w1. Very simple, okay? And with respect to x2, I'm saying that my weight is w2. I think this part is clear. Okay, I have explained in very detail that this is all about weight. Neural network is all about perception. All about the weight. We have to assign the weight, and this weight are random in the beginning. Okay, it can be anything. So here I'm representing this weight in terms of matrix. I want to do some method. I want to show you the mathematical calculation. So this W1, W2, I can represent in terms of matrix like this: W1, W2. Okay, because I have just one neuron, so I have just one column. Okay, so this weight is representing the weightage. Okay, I mean W1 is the weightage for X1. Let me explain that. This is the weightage for example, how the purchase will happen. Okay, to make a purchase happen, if somebody buy, which component in the salary and city, which component has a more weightage? Let's suppose if my salary is less, then the chances that purchase will not happen. Okay, if the salary is high, then the chances that people can purchase. So you can see that uh, with respect to this data, salary has more weightage. Maybe city can be, even city has weightage, I'm not saying that, but it is very clear from this data set that salary has more weightage. Okay, so this way we have to give some weightage. Okay, every input will have some weightage, and this weightage, how we initialize the weightage, it's completely random. This all thing I have already covered in my previous video, in the foundational video. You haven't seen that, please go and watch it. Okay, so this is my weight, and for this input which is coming into network, even I can represent into, like, in the horizontal row, like x1 x2. This is again a matrix, row matrix, right? And at the same time, every neurons, okay, every neurons has its own bias. This I already have covered. Okay, so let's suppose I have one bias b, like I can represent like this because I have just one neuron. Okay, I don't have multiple neurons here. So this is my setup, this is my data setup. Okay, so I have input matrix, I have weight matrix, I have the bias matrix. These are the fundamental thing required to build the network. Okay, and here this weight and bias are completely random. It can be anything. Okay, in the network. Okay, now once we have assigned the weight and bias and all the, we have the input. Okay, then if the data flow into this network, like data is coming from here, from this point to, it is coming from this point to coming to network, it is going from this point to coming into network. Okay, so if the data comes into network, we perform one mathematical calculation which I have already covered. What we do here, we do x1 w1. Okay, so we multiply, we generally we do a dot product, it's a kind of dot product, right? So we multiply x1 with w1, we multiply x2 with w2. So this is, and when we do a summation, x2 w2. Okay, and then we add a additional weight. This is what we do. This is the what we do the mathematical calculation. Okay, so this become this data. Okay, so till here, so this neuron is receiving this input. Okay, and if you receive this input, okay, the second part, what we have to do, we have to perform some action on it. Okay, so this is called activation function, which is a step function here. Okay, so once you get once you get this input, let's suppose this is my input, then what next I need to do, I need to apply a function on it, okay, and this function is what, it is a step function, right? We already covered that. This is a step function. Okay, so what the step function does, a step function, it depends upon the input. As you know, if input I'm representing by x, if input is 0 or more than 0, that is when see that the output will be 1, right? This is what the step function does. And if the input is negative, then output will be 0. This is what we have seen. Okay, so here what will we do, we will calculate this value. Okay, and this calculation is just like a dot product, and which is quite easy to do. We can do that. Okay, because we know the x1 and x2. In this case, what is my x1? X1 is 2k and x2 is 1. Okay, so I have here, in this case, my x1 is supposed 2 and x2 is 1. I have the data. Okay, and w1 w2 b, we have already initialized some random value. Let's suppose I'm giving, suppose I'm w1, I'm saying 4. Okay, and w2 I'm saying 2, right? So 2 plus 2 into 4 become 8, 1 into 2 become 2, and b, suppose I have some bias 1, I'm giving some random number. Okay, so it become 1. So this way I can easily calculate this whole operation, this whole matrix operation, because I have all the data. There's nothing unknown here. I have x1, I have x2, I have b, I have weight. Okay, I have everything. So now after calculation, it becomes 10 plus 1 11. Okay, and on this 11, this 11 will this whole thing become 11. Okay, and on this 11 we perform some activation function, which is step function. So step function, for this step function, input is what, input is positive, 11 is positive, so the output will be 1. Okay, so for this whole calculation, it will give the result is equal to 1. I hope you got it right. So for this input x1 x2, I mean for this row, okay, for the first row, my calculation is coming 1 according to the input and according to the step function. Finally, it is giving me for one row, first row, it is giving me 1. Okay. Similarly, same thing I can do for second row, 3 and 2 again. So only my 3 2 will change. Okay, again I have some weight and bias and I do calculation. So you can see that for every rows, okay, we can perform matrix calculation, and we on the matrix calculation, whatever input we'll receive, we will perform the step function, and the step function finally will produce one output, either 1 or 0. This is how the matrix, this is how the mathematics happens behind the perceptron model. Okay, one thing I want to talk about here. Okay, let me let me remove this. If one thing I want to talk about here, which is kind of, I want to represent this whole calculation in a mathematical formula. Okay, so my intention here is what I want to give a formula, because you know that everything happening math here. So I want to represent this whole thing in a mathematical formula. How to do that? Okay, so here you can see that in order to just create a mathematical, just I want to not I want to generalize it in a mathematical formula. So here what I can do that, uh, yeah, so you can see that actually what we are doing operation here, we are doing x1 w1 plus x2 w2, okay, and plus b. This is what we are doing, right? The mathematically. So this portion I can represent like x I wi. Okay, I'm just putting a formula there, and I can do a summation. Okay, and I from 1 to n and plus b. Okay, so this whole thing, I'm trying to just show the formula. Okay, so this whole thing actually in this network, this is what happening. So if I want to represent this whole thing in a formula, this is the formula, and on that we are applying a function which is activation function. Okay, and this is giving the result, this is giving the y prediction. This is what happening. If you want to show represent this whole equation or formula in terms of formula, then you can represent the whole thing into this format. Okay, I hope you're getting it. You are able to understand the formula, how the formula working. Okay, okay, one thing, let me okay. Mm, now let me I hope you are able to understand what the calculation happening. Okay, now let me talk about training part. Okay, a training part I will cover in a very detail. Okay, but here, uh, okay, let me draw again. Okay, so you now you are able to understand the flow, how the data goes into network, what are the metric calculation happens, how the step function perform, and finally it give a result which is called prediction. Okay, so the training part, let me again iterate here. Let us understand the training part, and this will give you intuition. Okay, so here my purpose is to build an intuition, mathematical intuition of perceptron model, how it works. Okay, so, suppose I have I have two data. I have two features. One is a salary, one is the city, and one is the purchase. Okay, I have taken just two inputs, two features. Okay, and this is my model. This is simple network, and I have two inputs here, and two inputs are going into one neuron. Okay, and this will do, let's suppose this is x1, this is x2, this is w1, this is w2. So it will perform x into w summation. Okay, I from 1 to n. Okay, and a number of inputs, and after that it will perform z, I mean step function. Okay, and then it will give a result. It is called y predict. Okay, so basically it is building up, it is doing a prediction. Okay, so how it works? So let's suppose here my salary, suppose my first row, suppose my salary is 2 and city is 1. Okay, and let's suppose the real value is, suppose purchase is, yeah, it is purchase. Okay, so this is called this column is my real y, I mean the real value. Okay, so for input 2 and city 1, the purchase happen. This is the real, this is my training data, this is my the real data training, I mean the purchase happen. Okay, but let's suppose I feed this data, I feed here 2 and 1. Okay, and I'm doing a training and I have some weight, I have some bias. Okay, I have some w1, I have some w2. Okay, and I have some for this node I have some bias. Let's suppose this is the setup right now. Okay, and the input is coming 2 1. This is my input coming. Okay, and after the mathematical calculation which already shown you, it will produce a outcome. Let's suppose y predict, and let's suppose it is saying is equal to 0. Okay, because after a step function, either it can be, the result will be either 1 or 0, as you have seen that. Okay, so here you can see that for this input 2 1, my prediction is coming 0, but actually in the data set it is 1, right? So here, what do you mean with that? That your prediction, whatever it is predicting, it is not correct, or it is called misclassification. Okay, so at the training part, what it does, it will, it is called back propagation. What it will does, because we know that we compare. Okay, I will explain the training part in detail. So I found that my prediction is wrong. My model is doing a wrong prediction. Okay, so how we find that? Because we do comparison. We find the prediction, okay, from the model, and what is my real data. I can do the comparison, right? And if I find that if the comparison is not accurate, or my model is giving wrong value, which is not actually equal to my real data, I mean it's a misclassification, then I will go back. Okay, I will go back and I will make some adjustment, or I will do some correction in my weight w1, w2 and v, because these weights are completely random. I don't know the exact or accurate value of W1, W2, and B. This I have just assumed it. Okay, I have just put some random value. So as part of training, it happens training. It go back and it will update, and it will become some W1 dash, W2 dash, some new weights. Okay, and then B dash new weight. Okay, now you might be asking how this calculation happens, what is the math behind it. It's a part of training. I will create another video, maybe second next video. But right now, what I want to build an intuition. This is what exactly happened. Okay, you do a forward propagation. This portion is called, in the forward direction, you're moving in the forward direction, and in the forward direction you're doing what? Matrix calculation. This input weight bias, you're doing a matrix calculation, and you're producing a result. Okay, and the result is not matching, then you are going back. So going back is this, the first one is called forward propagation. I already covered in the previous video. And if we find that there's a misclassification, we go back and we update my weights and bias, these all things. It is called backward propagation. Okay, now the question is, what is the math behind it, how we update our weights and bias, that's I will cover later. But right now I want to build intuition. This is what happened as part of training. This is the whole process of training. Okay, and this is the maths involved here. So in the first, in the forward propagation, we do matrix calculation in this direction, and if there's a misclassification, there's a math involved again, which will update the weight. Okay, so now for the second input, let's suppose here my second input is, suppose this happening with respect to first input. Okay, so with respect to first input, in the forward propagation, it will do the matrix calculation, it will produce result, it will do the comparison. If there's a misclassification, it will go back and it will update my weight and bias. This is one cycle. Okay, now for the second input, let's suppose I'm taking my second input is 3 and city is 2. Okay, and I'm saying that uh, the result is 0, I mean it is not purchased. Okay, let's suppose it has not purchased. Okay, now After my first iteration, my already weight and bias has been updated. Okay, so now for the second time, I will give 3 and 2 my input. Okay, and this is my weight and bias because it has been already updated, and again it will perform this action, forward propagation. It will perform the matrix operation. I mean, it will multiply and add bias. Okay, and finally it will produce, of course, outcome, prediction. Okay, and let's suppose, I'm just assuming hypothetically, let's suppose my prediction is also coming 0. I mean, it is not purchased. Okay, and this is my prediction, and what is my real outcome? My real input is also 0. Okay, so my prediction, the model prediction and actual value is same. There's no difference. Okay, in this case there will be no update because there's no any problem. Okay, there's no any error in the model. The outcome which is coming from the model, which is the prediction, and the actual value, it is same. So there's nothing to do anything, right? So here there will be no update in the weight. So here in this case my weight will remain same. Okay, again there will be a backward propagation, but during the backward propagation it find that because my the result is same, there's no change, there is no any need or requirement to update my weight. So my weight will again here remain the same. This is how it happens. Okay, now let's suppose I have third one. Suppose suppose I'm taking third input. Okay, suppose this is the salary is 4 and city is 1. Okay, city suppose 3, and I'm saying suppose purchase happen. Okay, so again the next time I will process my third row, so which is 4 and 3. Okay, so now here I will process 4 and 3. This is my input, and my weight and bias is again same because in the previous iteration there was no update. Okay, and again it will perform the forward propagation against this input and this weight and bias, and it will produce an outcome, y predict. Okay, and let's suppose that my outcome is coming, suppose I'm saying it's 0. So my prediction is saying it is not purchased, but actually it is purchased. You can see in my data set. Okay, in my data set it is saying it is purchased. For this input, purchase happened, but my model is saying purchase not happened. So you can see that there's a mismatch, there's a misclassification. Okay, so whenever there's a misclassification, it will go back as part of backward propagation. Okay, and whatever it was the weight and bias, so this is my weight and bias, right? So this will get updated, so it becomes new. Suppose w1 2 w2 2, this is my new weight and bias weight, and suppose uh, weight bias w dash 2, this become my new weight and bias. Okay, so you can see it's a iterative approach. It happens in a loop. Okay, this whole training happens in a loop, in a iteration. Okay, so this is how the training happened. Now you might be asking this question, I know that okay, how this update happens. Okay, how this update happens, I will not going to cover in this video. I will cover in the next video where I will teach, I will discuss the whole mechanism behind the training part. Okay, so this is how happened, this is how the whole network work. I hope you're able to understand the whole concept, how the forward propagation work, how the matrix calculation happens, and if something if the result is produced and if it is not matching with the real data, then it will update my weight and bias. Okay, so this is the crux, this is the summary. Okay, this is the mathematical concept or summary. It will do the forward propagation where it will do the matrix calculation between x and w and b. Okay, and it will apply the f on it. It will produce a result. Okay, y prediction. If y prediction is not if it is not equal to y, actual y, it will go back and it will perform backward propagation, and it will update my weight, new weight, and new bias. And this whole thing happen in a loop, in iteration. Okay, and this is what happens in the uh, inside the neural network. Okay, this is the mathematical intuition. I hope you're able to understand. Now in the next phase, if you're able to understand the mathematically that what are the calculation goes behind the scene, I hope you're able to understand now. Now let us talk about the geometrical. Okay, now I want to think, I want to create another intuition based on the graph. So graphically, let us understand. So this is my geometrical intuition. Okay, I want to build this geometrical intuition, that what happens basically. Okay, this, because this is very important to understand. Okay, so again, suppose this is my data set. Again, let me just, let's suppose this is my data set. Okay, and with this data set, let us suppose this is my salary, this is my city name. Okay, and suppose purchase happened or not happened. Okay, this is my data set. Okay, and I have some, suppose salary is 2, city is 1, suppose purchase happened, suppose city salary is 3, city is 2, purchase not happened, and suppose salary is 4, city is 3, purchase happened. So this way I can have multiple rows, multiple things. Okay, and I will have one column like purchase happen or not happen. Okay, so you can see that I have two class. If you know what is the classification problem, so it is a typical classification problem. So if you understand this data set, you will notice that I have two classes. One is the purchase happen, which is representing by 1. One is purchase not happen, which is representing by 0. Okay, so this point, okay, let's suppose uh, I can represent this point in a x-axis in 2 dimensions. Okay, why I can represent into 2 dimension? Because I have 2 features. Suppose I have 3 features. City, suppose I have salary, I have a city, let's suppose age. I add one more feature like age. Okay, so the purchase will happen on the basis of what is the salary, what is the city, what is the age. I can add multiple dimension, and generally in the data set you will find multiple dimension, 3, 4, 5, 6 multiple dimension. But here, to just explain the concept, I'm taking 2 dimension. Okay, so this point I can represent into 2 dimension, in x-axis, in y-axis, because I have 2 features. Okay, so let's suppose I'm creating, you can see that I'm getting we have 2 segments or 2 cluster. One cluster, one are the this combination, like 2 1 purchase happening, 4 3 purchase is happening. So I have 2 cluster here. Suppose I can, let me change the color. Suppose here I'm saying that these data points. Okay, suppose this point, this point, all the green point. Okay, these green points. Okay, so these green points are a cluster for people who does the purchase. Okay, and I have another cluster which the people, let's suppose these people. Okay, these people, the red one. So these are the cluster, these are the people who have not purchased my product. Let's suppose I have this representation. Okay, so graphically, if I have two features, salary, city, I can easily plot in a 2 dimension, in x and y dimension. Okay, so green is representing the people who have done the purchase, and red is representing the people who have not done the purchase. Okay, now if you know the machine learning, then you can easily build this intuition. If I ask you, my task is that I want something. Okay, so that I want to build a model, or I want to train my model, so that my model can differentiate, or I can say I have to build a boundary between these 2 clusters, so that I can easily differentiate this. Okay, this is my task, this is my model task. Okay, so in this case, if I have 2 inputs like this, 2 axis or 2 dimension. Okay, so in this case, how to create a boundary between this cluster, green cluster, and the red cluster? It's very simple, right? I have to just draw a line. So in 2 dimension, if you really want to separate 2 entity, 2 cluster, you need a line. Okay, so you can see that beyond, above this line, anything, suppose so let's suppose I find, let's suppose after training, hypothetically I found this line. Okay, and if new point, let's suppose I have trained, this is my training part, and once the model is built, I have deployed this model in production, and let's suppose I'm getting new inputs. Okay, let's suppose I'm getting salary is equal to 5, and city is equal to suppose 4. Now for this input, for this combination, I need to predict whether this person will purchase or not purchase. I want to do the prediction. Okay, so if this point 54, this point is below, above, let's suppose this point comes here. So this point, because it is above the line, I mean it's a part of this cluster, I mean they will purchase. But let's suppose if this line fall below this line, let's suppose here, because this point is below this, falling below, so this is very close to this cluster, right? So they will not purchase. Okay, so this is what the graphical representation of perceptron. So what the perceptron does, uh, it is more like it classify two groups. Okay, if it is also called binary classifier. Okay, perceptron is also called binary classifier. Okay, so it tried to uh, classify or separate or segregate two different set of groups. Okay, so how to segregate those two groups? So if you know the graphs, okay, so if it is a two dimension, if you have a two features like this, okay, then we have to draw a line. Okay, if we have two features, okay, if we have a two features, then we have to draw a line, a boundary which will separate my groups. If I have three features, okay, let's suppose I have a salary, I have a salary part, I have a city part, and I have an age. Okay, so these three combination will determine whether purchase will happen or not. So it is a three features. So in the three features, we draw a plane. Okay, and suppose I have more than three features, four dimension, more than three features, or three more than three features. Okay, uh, more than three features. In this case, we draw hyperplane. Okay, I think this is all basic, you understand. Okay, so in two dimension we draw a line, in three dimension we draw a plane, and in three dimension we draw hyperplane. And as a human, we cannot see or visualize three dimension. Three dimension we can visualize. Okay, but yeah, in the four dimension we cannot we I mean more than three dimension, like four dimension, five dimension, six dimension, as a human it's very difficult to visualize or sense it. Okay, but we can do the mathematical calculation, but maybe we are not able to visualize it. Okay, but this all happen. Okay, so you can see that geometrically, graphically, what you're trying to do as a part of training. Okay, as part of training, what you're trying to do here, either you're trying to find a line, you're trying to find the best line which will separate two groups or two cluster, or you're trying to find a plane. Okay, suppose I have three dimension. Okay, then you're trying to find a plane which will separate your cluster. Or suppose I have five dimensions, six dimensions, then you're trying to find a hyperplane. Okay, so basically your aim is what? To find a best line, or best plane, or best hyperplane which can segregate or separate my cluster. This is what is the whole purpose of perceptron model. Okay, so this is what, so geometrically this is what happens. Okay, if you, let me remove this, let me explain, let me establish this concept from the, let me prove this concept from the mathematics. Okay, so it was a concept I discussed with you, this was a concept. Now for to just explain this concept, or whatever I'm explaining, whatever I'm saying, okay, let me proof this with the math. Okay, okay, all right, so I hope you got it right. So how to prove this math? If you know that, let me prove this. Let's suppose this is my neuron. Okay, and this is my, suppose I am taking two input, x1, x2. Okay, and after that I'm performing, suppose my step function, and I'm getting the result, outcome, right? So if you see the mathematics, and suppose I have a weight 1, weight 2, right? So if you see the mathematics, what we do actually in the forward propagation, what we'll do, what is the mathematics? The mathematics is w1 x1 w1 plus x2 w2 plus b. Okay, and on this I apply some function, right? So if you think, if you pay attention, this equation x1 w1, x2 w2, and b, this equation, it has two dimensions, x, because I have two features, I have x and x1 and x2, I have two features. So in these two features with this equation, it is representing what? Just think about it. Just stop the video and think about it. What this mathematical equation representing graphically? It is representing a line basically. This is a line. Okay. So here basically what we're doing here, when we do this operation, when we do this matrix operation, we do a dot operation. Okay. So basically we are creating a line, right? And I'm saying that if this line, if this input, what I'm doing here, if I, whatever line I got, x1, w1, x2, w2, and b bias. Okay. Here I'm taking the magnitude. If it is more than 0 or 0 or more than 0. Okay. Now think about, suppose if I have a line like this, suppose I have a line 2x plus 3y plus 4. Okay. And if I create like this, okay, so it is mathematically, it is called inequation. Okay. And inequation graphically represent a reason. This is a reason. Okay. So anything, so it's a straight line, right? So I can draw, so 2x 3y plus 4, that can be represented in x dimension and y dimension as a line. This is a line, right? So let's suppose this is a line. So I got this is the line 2x plus 3y plus 4. Okay. So if I say that 2x plus 3y plus 4 more than 0, I mean this is this line. I mean above this is the, because this line is creating two reasons. This is the one reason above the line, okay, and another is below the line. It is creating two reasons, right? This is the, another is this reason, the green reason. Okay, I can say this is above the line, above line, and this is the below line. Okay, below line. So it is creating two reasons. Okay, so here I'm saying that this is what, so suppose I got input, I did some I did my matrix calculation, I got, suppose this line 2x plus 3y and more than 0. So let's suppose if I'm saying that, let's suppose this is coming 2x 3y plus 4, after calculation it is coming 0 or more than 0. Okay, I mean if it is coming 0 or more than 0, I mean I'm in this, I mean where I am in this region. I'm talking about this region, above the line region. Okay, so if I apply z, or if I apply here f step function, then I'm saying that it is 1. So here basically I'm creating a group. Okay, so all the point which are above this line, they belongs to one group. I'm just giving, I mean purchase happen, I mean it's a one group. Okay, if suppose if it is less than 0, then I'm saying if less than 0 means what, all the points, I mean these points x y are the below the lines. Okay, then I'm saying it is 0, I mean it belongs to 0 group. Okay, so basically this matrix calculation, whatever you're doing the matrix calculation, x1 w, x2 w plus b, basically you're drawing a line. Okay, if let's suppose you're using two features, then in the two feature it's a line, because it's a two dimension. Okay, so in the two dimension basically this perceptron, okay, this perceptron, what it's doing, this perceptron is trying to draw a line. Basically it is drawing a line. What, it is trying to draw a line. Okay, and it is trying to find a reason whether this points, whatever inputs you have given x and y, whether this input is above the line or it's below the line. If it is above the line, they will belongs to one, I mean one group. If they are below the line, they will belong to one group. Okay, so geometrical, graphically, what the perceptron does, it try to create a line in two dimensions, and based on the line it try to find the reason. If reason is positive, then you apply a step function. If it is positive, then inputs are falling into one group, maybe a purchase group. If the input is less than 0, I mean the reason is negative below the line, then they're falling into second, another group. So this is what it is trying to classify the point, either above the line, first it will draw the line and it will classify either above the line, either or below the line. This is what it is doing graphically. Okay, so this is the geometrical intuition behind that. I hope you got it, right? So if somebody asks you what is the perceptron model, so perceptron basically it trying to find a line, and it try to find two regions, okay, above the line regions and below the line regions, and on basis of that it find two groups. Okay, this is what happens. So this happens with respect to x and y. If it suppose I have a three features, okay, let me draw a plane here. Okay, in case of three features, let's suppose I have x feature, I have y, okay, I have a z, this feature. Okay, suppose I have the input, I have x1, I have x2, I have x3, suppose. So x1 is, let's suppose it's a salary part, x2 is suppose ct part, and x3 is the age. Okay, so these three things will determine my purchase happen or not happen. So in this case what happens, if we perform this action x1 into w1, x2 into w2, x3 into w3. So in this case I have three weights, okay, and bias. So basically in three dimension, in x1, x2, x3, it will create a what is called hyper plane like this. It will create a hyperplane, plane. Okay, and if any point, suppose this is more than 0 or greater than 0. Okay, so again this plane again creating two segment or two parts. One are the area which is the above the plane. This is one segment. Okay, though it is in the three dimension. So let's suppose this is my plane. Okay, this is my plane. So there are two segments. One is which is above the plane and which is the below the plane. Okay, let's suppose I'm pointing to point. So let's suppose this red one. Okay, suppose this red one, this point. Okay, so this point is above the plane. Okay, and let's suppose this point, blue one, this is below the, this point is below the plane. Okay, so this plane is trying to separate, it is creating two segment above the line and below the line. Okay, so this if this value is more than 0, I mean it is above the plane, then it is saying that it will be 1 after applying a step function. I mean it's a part of one group. So this way, basically you are the graphically you can represent, I repeat, graphically you represent the perceptron either as a line if it is in two dimension, or plane or hyperplane, and it create two regions. Okay, either above the line or below the line, and this way it creates two groups, right? So this is the representation, graphical representation of perceptron. This is how the perceptron will work. Okay, okay, so this is all in this video. So I hope you're able to understand. Let me repeat that what is the perceptron mathematically, what it does. It does the matrix calculation. Okay, and we can represent the whole equation formula. We can create a mathematical equation like this. Okay, and the important thing is to understand the training part. Well, I will cover the training part in detail, that how the training happens, how the forward propagation happens, what the mathematical calculation happens, and what the backward propagation happen, how the update. Okay, how the update happens, it's a different, I will cover in different class, but this is the mathematical intuition. Okay, and it's a iterative approach. It happens in a loop, and geometrically this is nothing but a line. Your perceptron is represented either by the line or plane or hyperplane. Okay, this is the geometrical intuition. Okay, so this is all in this video, my friend. I hope you now have the understanding or intuition of what is the perceptron, how it does work, what are the mathematical calculation, and how to represent geometrically or graphically. Okay, now the next question is, I could not solve or answer the question that this part. Okay, how the training happened. Okay, I mean how the this I told, right, this update, the way it happens, this how this update happens, how the training happens, right? So for the training part, okay, I will talk about in the next video that how the training happens in the perceptron. I mean how this whatever weights I have and whatever bias I have, how this updation happens. This will I will cover in the next video. Okay. Till then, goodbye. This is all in this video. I hope you have some better understanding about perceptron. I will see you next video. Till then, goodbye. Take care. And if you like my content, please do subscribe my channel. It will help me to grow in my channel. Okay. This is all from my side. I will come back next video. Till then, goodbye. Take care.